Okay, so today, now, we're going to talk about the last section of chapter 4. That means we're going to look at the tidal effect, which we introduced at the very end of chapter 3. So the end of chapter 3 connects with the end of chapter 4. Chapter 4, section 6, 4.6, the tidal effect, first Earth on Moon, this video, and then I'll follow that with Moon on Earth. We'll see that Earth on Moon gives a synchronous spin orbit, sometimes called just a synchronous orbit, but I think a synchronous spin orbit makes more sense and gets the point across. And then Moon's effect on Earth is ocean tides. Okay? Here, we'll see if there is a dark side of the Moon. And here, we'll see if we can blame a full moon for our mood. So, is there a dark side of Moon? And can we blame a full moon? Let's take a look. We'll be able to answer this very simply with some interesting things about this. Okay, so let's go over here and take a look at the book. All right, this is a quick review of what we learned at the end of chapter 3, which is, we know that gravity gets weaker with distance. Just like light appears dimmer with distance, sound sounds softer, not as loud, with distance because it spreads out. Now, is that why gravity gets weaker with distance? It's a way of thinking about it, and I won't go into that right now, and we won't get into Einstein's correction of forward space-time. But nonetheless, if we double the distance away, it actually gets 2 times 2, called 2 squared, or 4 times weaker. If we triple the distance away, it gets 3 times 3, 3 squared, 9 times weaker. So that's the way gravity works very well. That's the Newtonian view. Nonetheless, if then fist A, this my left fist is pulling on my right fist, my left, which it is, I believe, but I can't feel it because it's tiny, because these things are tiny, but I believe that my left fist is pulling on the side close to it stronger and the side far from it weaker. Any two objects. My fist on this ball, it pulls on this side stronger, this side weaker. Here, if the face faces my fist is pulling stronger on the face and weaker on the back side. That's all the gravitational tidal effect is. It's called the tidal effect, gravitational tidal effect. It's not just for ocean tides. It's a big player in the universe. And thankfully, it's fairly simple to get an idea, because if gravity gets weaker, it's going to pull stronger on this side and weaker on the far side. Stronger on the near side, weaker on the far side. That's all there is to that explanation. Let's see what happens. And so what happens, I will summarize over here. Get this out of the way. There's the summary, and you see it in the text. So let's see how this works. I messed up my glove. Oh no, I think I can live without that. Let's do that. Let's see how this comes to be. So I'm going to come back over here, and I'm going to scroll and talk about the text picture. And I'm going to try to tilt this a little bit for you. Taking a look at that. Sorry. All right. Suppose that's sufficient. Not so great. How's that? All right, maybe a little happier. Okay, so we're going to talk about this picture. And imagine Moon. Imagine that Moon is a rectangle, just easier to see. I really should have flipped this black and blue, but nonetheless, that's the way I have it right now. Second edition will have it flipped. For this picture, I've got blue down here. Imagine the moon's going along. Newton's first law says that any object in space, if there are no forces on it, will just go in a straight line. If it's turning, going on a curved path, it must be pushed or pulled upon. There must be a net push or pull. So gravity from Earth is, we blame Earth for exerting a pull of gravity on Moon and pulling it into orbit. We'll see in chapter 6 where Moon came from, and we'll see that a lot of this really, it took longer than what I'm saying here, but eventually it settled down because of the subtle effect. So gravity, sure, keeps Moon in orbit. If Moon stopped, gravity would pull it and it would crash and it would be a not so good day. But because Moon is moving, just like a friend moving past you, if they're just standing there and you pull them, they'll come towards you. If they're going past and you pull on them, maybe they got a rope tied to their waist, then they'll kind of curve around you, right? Just like that, try it. So gravity is responsible, but there's an extra effect called the tidal effect. Earth pulls stronger on the end or near side, the close side, and pulls weaker on the far side, right? And if you think about that, as Moon is going by and it gets pulled stronger on the near side than the far side, it kind of trips Moon. Now we know that Moon is in fact a sphere, so we can think of it that way, but still the idea works, and this is a good enough introduction to this effect, and you get cool effects. All right, we're rolling. So there's that. Gravity causes the orbit. Eventually, we'll talk about that. But this tidal effect, after quite a long time, you can look that up if you want, settles our Moon into what's called a synchronous orbit. And that means that Moon is pulled stronger here, weaker there, and tilts. And it's set up into this orbit where it takes the same time to go around as it does to spin once. Let's explore the possibilities that an object might have orbiting. So let's say Moon does not spin. We haven't talked about Moon spinning yet, and I told you we'd wait until now. If Moon did not spin, let's talk about which side is lit and which side is not lit. And let's talk about what side is near and what side is far. We're going to compare those. And you can see it from this picture. It's all there. So it's like anything. Just get a little acquainted. You'll master this. And it's, I think, really cool. Okay, so if I go around like this, what side is near? The blue side. What side is far? The black side. See, I should have done it the other way. Why? If I did it this would make more sense. I could even do an orange side, but forget about those colors meaning anything. The blue side is near us, the black side is far from us. Which side is lit? Of course, the side facing sun is lit. And whether or not Moon is spinning, the side facing sun will always be lit. Whether or not Moon is spinning, just like Earth, the side facing sun is lit, that's daytime, but we spin out of the light and into the light and out of the light and into the light. So, hold up. What if Moon was not spinning? Then the black side would be lit and the blue side would be not lit. And as Moon orbited, if Moon was not spinning, the black side would always be lit and the blue side would always be not lit. That's what I said. The other side should have flipped the colors. It's all right. Right? So we would have one dark side of the Moon if Moon wasn't spinning. Now, if that was true, from Earth we'd be able to see the blue side, although it's hard with sun there, but we'd see the blue side. And was not spinning, we'd see this side. And then we see the black side. So now the black side is near us, moon not spinning. This is not what's the case, but as an example to think through. Blue is near us, black is near us. So if moon was not spinning from Earth, we would get to see all sides of moon. And there would be one side that always stayed dark, and we could talk about an actual dark side. That's not what's happening. Moon is spinning. What if moon was spinning fast? We spin once every 24 hours. Doesn't feel like we're spinning fast, but we are. And so if moon was spinning fast, which side would be dark? Blue. If it was spinning fast, blue would be dark, black would be lit. Now blue is lit, black is dark. Blue is lit, black is dark. If moon was spinning fast. That's not what happens either, but this is the other extreme. If moon is spinning fast, there would be no side that stays dark, and there would be no side that stays near us. Blue is near us, black is near us. Blue is near us, black is near us. Blue is near us, black is near us. No side that stays near us, no side that stays dark if moon were spinning rapidly. What's the case? The case is this. It's true, wherever anything is in space, the side facing the light bulb is lit, the light bulb of sun. The other side is dark, there's the terminator, and from space we don't see phases, we just see that. From Earth you see phases. Not worrying about phases now, let's take a look. What's true now? What's true is, let's look at the spin. If I start here and I spin 1/4 of the way, 1/4, 2/4, also known as half, 3/4, and 4/4 of a spin, a full spin. So that's what that would look like, right? 1/4 of a spin. Now let's look at orbit. As it orbits, 1/4 of an orbit, 2/4 or half of an orbit, 3/4 of an orbit, 4/4. And because of the stronger pull on the near side, called the what? Tidal effect. The stronger pull of gravity on the near side than the far side, moon settled into a synchronous spin orbit, where, as it orbits 1/4 of the way, it spins 1/4 of the way. So when I orbit 1/4, it's going to spin 1/4. Blue's going to be over there to the right, and it happens gradually. Orbit 1/4, spin 1/4. 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 Orbit 1/4. About how many days to orbit once? New moon to a new moon. We're just going with about 4 weeks, right? 28 days, about 4 weeks. Okay, so 1 week, 2 week, 3 week, 4 week. About, good enough. When moon's over here, we know it's a new moon. Why? Because from Earth, we're going to see the not lit side. Still, moon's always half lit. So now, blue is not lit. As it goes around, right? Here it is, if you can see it. There and there. Now blue is lit. Blue is not lit. Blue is lit. And gradually, blue becomes less and less lit, and blue becomes more and more lit. Blue becomes less and less lit, waning. Blue becomes more and more lit. No side stays dark. There is no dark side of the moon. I mean, there's always one side of Earth that's dark, but we don't say that's the dark side of Earth because, well, after night follows day. Right? So So there is no dark side of the moon. And except there is an album, which you should listen to, by Pink Floyd, 1970, I think. Okay, so no dark side of the moon. This shows you there's no dark side of the moon. However, interestingly, notice this. There is one side, the blue side, that always faces us. And that side is sometimes not lit, a bit lit, half lit, mostly lit, all lit, mostly lit, all lit, mostly lit, half lit, a bit lit, not lit, waxing, 1 week, 2 weeks to full, waning, 1 week, 2 weeks to new. That's the story. Because of that tidal effect, let's summarize and I'll show you something cool. Good, we're still running. The summary is this. There is a synchronous orbit, about 28 days to orbit, and about 28 days to spin. That is a very slow spin, and that's important. There is no dark side of the moon. There is no side of moon that always stays dark. And there is, however, one side that is a far side, the far side that we can't see. And there is one near side. There is one side that is always facing us and always watching us. It's the close side, it's the near side. And then there's this other side that we can never see directly from Earth unless some spacecraft sends back an image to us, but we can never see that from Earth. That's the far side. So there's a little mystery, and that's kind of cool. And let's go over here and conclude this. Imagine if, and I'll do it this way as a side view, here it is, moon, as moon orbits, there's one side that always faces us, that side, the creepy side that's always watching us. However, as it orbits, it will appear more and more lit and less lit. There is one side that always faces us. What do we call that? The near side. And this? The far side. There is a near side. There is a far side. One side that's the far side. And is there a dark side? No. Take a look at this picture, and I think you will see what I'm talking about. The same side always faces us. Remember that the sunlight is coming from way out there, 400 times farther away than moon. Sun is way out there. Right? Earth is a grain of sand. Sun is a softball, like 10 long steps away. Earth is here, and moon is right there on our pinky tip. Okay? So it lights Earth, it lights moon as it goes around. That's what we see from space, from our spacecraft, our friend. And but it does, moon is spinning. And so I like to draw this. Let me draw it here. A nose and some eyes. Right now, our near side is not lit. Let's throw some ears. The near side is a bit lit. The near side is half lit. The near side is mostly lit. The near side is all lit. You know the phase names. The side facing Earth, mostly lit, all lit, mostly lit, waning to half lit, waning to just a bit lit right there, waning to new. In about 1, 2, 3, 4 weeks, close enough. Got it? So there is a near side. It's creepy. It's always watching us. However, there is not one dark side. Let me conclude with some photos here and pull that up, and you've got this little lesson. So take a look, and all you got to do is get on the internet, and you will take a look and see that. And it looks a little distorted here because of the location of this. In fact, let me just pull that over here for you. A little better for you. All right, all you got to do is get on the internet and check it out. And you can see that, in fact, sorry guys, not bad. All right, a little better. Just roll over. All right. You can see that the near side is the interesting side. Yay! So at least the side facing us is Moon's face. The far side is rather boring, like the back of someone's head. So that's good news. We will talk in chapter 6. What's the light part? What's the dark part? What's the name of that thing? All right? But we see that's the case. And what you probably didn't notice when you saw this clearly kind of horribly done picture, because look, it's like we're looking through Moon and you can see stars, and stars can't be in front of Moon because stars are incredibly, light years, many light years away. That doesn't make sense. But anyway, look at this. New Moon going into a waxing crescent, and look at the side facing us is always the same side. It's just not lit, a bit lit, half lit, mostly lit, all lit somewhere in here, mostly lit, half lit, a bit lit, always the same side facing us. And we see the phases from Earth, not from space, because from space it looks half lit. Pull that all together, you've got it, and you're really in tune with observing Moon.